Welcome to our online chemistry class. Our topic is coordination compound. Let us discuss part number 1. So the most amazing field of modern inorganic chemistry is coordination chemistry. So one question maybe arises in your mind, what is coordination chemistry? So coordination chemistry is the branch of chemistry which deals with study of coordination compound or complex compounds is known as coordination chemistry. So for example, photosynthesis in plant involves chlorophyll, which is a coordination compound of magnesium. The red pigment hemoglobin present in blood, which is responsible for regulation of respiration process in the animal world, is a coordination compound of iron. So these are few examples. So therefore the study of coordination compound is highly significant from biological, industrial, analytical point of view. So coordination compound contains a central metal ion surrounded by number of oppositely charged ions or neutral molecules. So example is CuNH3 4 times 2 plus. In this complex, copper is the central metal ion while ammonia is the neutral molecule. And the bond between metal atom and these ions or molecule is called as coordinate bond. Then next one is Werner's theory. Basic postulates of Werner's theory. First one is most of the metallic elements exhibit two types of valences or valence. First one is primary valence and second is secondary valence. Second postulate is every metal ion tends to satisfy both the valences. Third one is every metal has fixed number of secondary valence. And fourth postulate is the secondary valence is always directed towards fixed position in the space. Then what is the silent features of Werner's theory that we have to discuss? First is principal valence is also known as primary valence or ionizable valence denoted by dash. In modern term, it corresponds to the oxidation state of metal ion. Then the primary valence are those which is a metal ion exercise towards the negative group so that its normal charge is satisfied by the formation of simple salt. So here one word is there, oxidation state, so that we are already familiar in redox reaction of 11th standard. So what is oxidation state? It is the charge present on that atom or ion when there is a complete transfer of electron from one atom or ion to another atom or ion. So every element is characterized by its fixed secondary valence, and the secondary valence is also known as auxiliary valence, subsidiary valence, residual valence or non-ionizable valence, and it is denoted by dotted lines. Now it corresponds to coordination number. Shortly it is denoted by capital CN. The primary valence are non-rigid and non-directional. On the other hand, secondary valence has directional properties. Then classification of ligands. So before seeing the classification of ligands, we must familiar with what is ligand. So the molecules or ions which are coordinated to the metal atom or ion in coordination compound is called as ligand or donor group. This is a Greek word ligand, Ligane, that means to bind. So in the previous example, CuNH3 4 times 2 plus NH3, that is ammonia, is a ligand. It is a donor group. So then types of ligand or donor group. First one is mono or unidentate ligand. The ligand molecules or ion which has only one donor atom or one point of attachment and can coordinate with metal ion at only one site in a complex. So for example, that NH3, in that only one donor atom is present, and that is nitrogen. Cn minus, OH minus, F minus, Cl minus, Br minus, O2 minus. These are some mono or unidentate ligands. Similarly, these are negatively ions. Some neutral ion may be there, that is ammonia, water. Okay. Then poly or multidentate ligands. Poly means many, multi means many. Ligand molecules or ion which has two or more donor atoms or point of attachment and can be like to same metal ion in a complex using two or more donating sites. So here EN, that means ethylene diamine, then EDTA, ethylene diamine tetraacetate ion. These are some examples of monodentate ligands. So let us see the classification of ligand and their examples. So types of ligand, name, abbreviations. So monodentate example is water, H2O, abbreviated by aqua. Ammonia, NH3, abbreviation is amine. Then bidentate means there are two donor group, ethylene diamine, NH2, CH2, CH2, NH2, two NH2 groups are there. Oxalate, C2O4 2 minus, that is bidentate. There are two oxygen atom. Then dimethyl glyoxymeto, it is abbreviated by DMG. There are two nitrogens atoms, which is the donor groups or atom. Then tridentate diethylene triamine. There are again two nitrogens, that is NH2 groups and one NH group. So three nitrogens are the donor atoms. Tetradentate means diethylene tetramine. So there are two NH2 group and two NH group in this compound. And lastly, hexadentate ethylene diamine tetraacetate, that is EDTA. Here there are four oxygen atoms and two nitrogen atoms, which acts as a donor atom or attachment site. Then next one is coordination number. So number of ligands which are directly bonded to central metal atom or ion in a complex, that is called as coordination number. It is shortly denoted by CN. The coordination number of metal ion is influenced by several factors such as, first one is charge on that metal ion, second is charge on the ligand, third one is the relative size of metal ion and ligand, and fourth is force of repulsion between ligands. Then next one is complex ion. So complex ion is more or less stable charge aggregate form when an ion, mostly of a metal, is directly linked to a group of neutral molecules or ions. So charge number of complex ion. Net charge carried by complex ion is called its charge number. It is equal to algebraic sum of charge carried out by central metal ion and the ligand attached to it. For example, in Fe6 minus, the charge number is -4. Okay, because the charge on that complex ion is -4. Here the central metal Fe is bonded with 6 cyano groups. So what is coordination number of Fe in this complex? It is 6. And remember that CN1 minus is monodentate ligand. Then difference between double salt and coordination compound. So double salt, they are those molecules or additional compounds which exist in the solid state but dissociates into their constant ions when dissolved in water. So all are familiar with alum. Okay, it exists in solid state but dissociate in water and it gets dissolved in water. So it is a combination of two simple salt, potassium sulfate and aluminum sulfate. Now what is coordination compound? They are those molecules or additional compounds which retain their identity in aqueous solution and shows properties entirely different from those of their constant ions. So previously one compound is there, Fe6 minus. So this is a coordination compound which has a different property than the constant entities or ions. So next one is, so all these are coordination compound or complex compound. So what is the effective atomic number? It is shortly denoted by EAN. It is the total number of electrons around the central metal ion present in a complex and calculated as sum of electrons on the metal ion and number of electrons donated by the ligands. So for example, here metal and the compound, that is coordination compound of that metal, Then Z is the atomic number, X is the number of electrons lost by that metal, Y is the number of electrons donated by that ligand or donor group, and with the help of our formula the EAN value can be calculated. And what is the formula of EAN? It is the charge on that metal ion plus so the EAN value can be calculated by using the formula Z minus X plus Y, where Z is the atomic number of the metal, then X is the number of electrons lost during the formation of metal ion from its atom, and Y is the number of electrons donated by the ligand. Then see the nickel is the metal, complex is NiCO4, atomic number of nickel is 28, so Z value is 28. There is no electron lost during the formation of metal ion from this atom nickel, so 0 is the X value, and there are 4 CO, they donate 2 electron each, so 8 electrons, so 28 minus 0 plus 8, answer is 36. For Fe, atomic number is 26, Fe donate 2 electrons, so Fe gives Fe2 plus, so number of electron lost by Fe is 2, and there are 6 CN, each donate 2 electrons, so 6 into 2, 12. Fe is 2 plus, Cn is 1 minus, for 6 Cn it is 6 minus, so overall charge is 4 minus. So 26 minus 2 plus 12, so answer is 36. Similarly, cobalt in CONH3 6 times 3 plus, atomic number is 27, cobalt donate 3 electrons, so 3 plus is the charge, and lost value of electron by cobalt is 3. There are 6 NH3, each donate 2 electrons, so 12 is the Y value, and 27 minus 3 plus 12, 36. Then zinc donate 2 electrons, so G gives Zn2 plus, so X value is 2, atomic number of zinc is 30. There are 4 NH3, each donate 2 electrons, so total electron donated by NH3 is 8. It is neutral ion, neutral compound, so overall charge is the charge of Zn, so 30 minus 2 plus 8, 36. And platinum in PtNH3 6 times 4 plus, so atomic number of platinum is 78, it donate 4 electrons, so X value is 4, ammonia donate 2 electrons, 6 ammonia donate 12 electrons, 78 minus 4 plus 12, 86. Then in another examples, Fe in FeCN6 3 minus, the atomic number of Fe is 26, it loses 3 electron, the cyanide loses 2 electron each, 6 into 2 12, 1 Cn carrying 1 minus, 6 Cn carrying 6 minus, but charge on Fe is 3 plus, so overall charge on the complex is 3 minus, so AN value is 35. Copper in CuNH3 4 times 2 plus, copper atomic number 29, 1 copper donate 2 electrons, so X is 2, 1 NH3 donate 2 electron, 4 donate 8, so 29 minus 2 plus 8, 35. And PT in PT NH3 twice 2 plus atomic number of platinum is 78, it donate 2 electron, so X is 2, 1 ammonia donate 2 electron, 4 donate 8, 78 minus 2 plus 8, 84. So in this way you can calculate the EAN value, effective atomic number. Many time question it asks in your board exam, calculate the effective atomic number. So you have to write the what is the meaning of Z, X and Y, and then calculate the EAN value. Then next is names of anion containing metal atom. So metal, then names of metal in anionic complex, metal, and names of metal in anionic complex. Plus first one is aluminium, aluminate, chromium, chromate, cobalt, cobaltate, copper, cuprate, gold, aurate. So this is the Greek word, and from that word aurium is the Greek word of gold, or it is the anionic complex. Iron, ferrate, lead, plumbate, manganese, magnate, molybdenum, molybdate, nickel, nickelate, silver, argentate. Argentinium is the Greek word for silver. Tin, stannate, zinc, zincate. Then next is bonding in coordination compound. So Werner was the first to discuss the bonding features in coordination compound. There are many theories which can explain the nature of bonding as well as various properties of coordination compounds, and they are: first, valence bond theory; second, crystal field theory. Thank you for watching my YouTube channel Mukesh Kharge.